Hello, my name is Luke Shahan.
And I am Clayton Ramsey, and this is our accumulating project, PolyGen.
For this project, we wanted to explore how different programming languages can solve different parts of a single problem. We built a geometric engine that bridges two distinct paradigms, the functional programming, which uses scheme.
And object-oriented programming using C++. The goal was to create a system where Scheme acts as the architect, procedurally generating complex data, and C++ acts as the engineer, analyzing the data and rendering it into a visual scene.
And then here is our scheme file that I'm on right now. It operates in a linear pipeline. First, we have the scheme generator. It's a job that uses math and randomness to create a scene of shapes. It outputs the scene into an intermediate file called shape.txt, which you will about to see.
In the other tab here, we have our C++ file analyzer, which picks up from that file of shape.txt. It parses the data and turns it into C++ objects, performing physics calculations like area and perimeter, and finally rendering the image.
All right, and then we're going to go back to the scheme. The reason I use Scheme is because it lists processing abilities are perfect for generating data. You can see here that I'm using a higher function like map, as you can see all through here. Like we have map right here, map, instead of just like regular functions. For example, in the make poly function that we have right here, I'm not using a loop. I'm using a map function across the range of numbers. This uses trigonometry to calculate the vertices of a polygon based on the number of sides. This allows me to generate random circles, rectangles, and polygons with pure functions without having to worry about memory state.
Going back to Analyzer, on the C++ side, we focused on object-oriented design and polymorphism, the core of this engine in this abstract base class, shape. It defines virtual functions like getArea and draw to SVG, which then derive oh geez then have which then have derived classes like rectangle, circle, and polygon to inherit from this. This is where the power of OOP comes in. The main engine doesn't need to know the shape of its drawing, it just has a list of shape pointers that it adheres to. It loops through them and asks them to draw yourself or calculate your area, and the specific object handles the logic.
All right, and then we're going to do a live demonstration on how both of these work. So right here, I am going to go into here. This is our terminal. For the first part, we just have to do, we'll go into this part. The racket right here is what runs the actual scheme. So when you press that, it generates it. Then it opens up a new file where you can see right here that is shape.txt. This is basically just for the C++ to read this part. It gives you all of the other, all the shapes, the numbers in it, everything that you'll need.
And then now we'll run the C++ analyzer to this.
All right, sorry, I just gotta find it. There it is.
All good. And as you can see, after it's run through in the console, we've generated a new file.
All right. And then right here, we just have to open it up.
And this is the generated SVG file. And as you can see here, we have constructed various polygons of circles, rectangles, and other shapes, all generated by the scheme and rendered by the analyzer here.
And then if we run it again, we get a completely unique procedural generated screen um, that will just basically just create a whole new scene for it. Um, for that to happen, though, you just have to run the racket again, and then you run the G++. And then again, analyzer.exe, and it gives you a whole new scene. In conclusion, this project showed us the trade offs of different paragrams. Scheme was incredibly concise for generating the math logic.
While C++ provided the structure needed to manage these objects and perform the heaviest calculations. By combining them, we are able to build a system that is greater than the sum of its parts. Thanks for watching.
Thank you.